Hi everyone and welcome back to another video of EDU PICO series. In this part we will learn to build a Wi-Fi access point network. By the end of this video, you will be able to build your own Wi-Fi AP network and enable EDU PICO to communicate wirelessly with other devices. Let's start with the basics. An access point, or AP, serves as a central hub for wireless communication. It acts as a bridge between the EDU PICO and other Wi-Fi enabled devices like smartphones and laptops to enable data sharing. This setup is very helpful for various applications, including IoT projects and remote control systems. This bonus section will guide you through the configuration for your EDU PICO to work as an access point. This means that you can connect to it, share data, and control it remotely all over Wi-Fi. This is how it works. The program starts the server and prints the IP address of the Wi-Fi access point. You can access the control interface by connecting to the Wi-Fi access point using a device like a smartphone or a computer. When you open a web browser with the server's IP address, you will see a web page with light on and light off buttons. Once you are on the web page, clicking these buttons will send the signal to the server, and the relay state will change accordingly. Messages like light on and light off will be printed on the shell console when the buttons are clicked. To connect it to your smartphone, simply connect the device to the same Wi-Fi and key in the same IP address to your browser. Let's start writing the code for this activity. Line 2 provides Wi-Fi functionality and socket communication. A socket represents one endpoint of a two-way communication link between two programs running on a network. Line 3 libraries for setting up a simple HTTP server. Line 5 to 10. This function configures the Raspberry Pi PICO W to act as a Wi-Fi access point with a specified SSID and password. If more than one EDU PICO is running as a Wi-Fi AP in the same area, it is recommended to set up different SSIDs for each board. Line 12 to 15. Configure GP22 as a digital output for controlling the relay. The relay is used to control the on and off of the USB light stick. Line 17 to 23. These functions update the state of the relay and print a message to the shell console. Line 25 to 44. This function defines the HTML web page with a title, a paragraph of text, and two buttons. The web page automatically refreshes every 5 seconds. When any button is clicked, the page will submit a post request to the server with the values clicked. The page will submit a post request to the server with the values light on or light off, respectively. This setup allows users to control the light connected to the USB relay by interacting with the buttons on the web page. Line 46 creates an instance of the server class with a provided pool and a static root. The static root may be used for serving static files like style sheets or images. Line 49 to 51 generates an HTML response with the HTML content using the web page function and sends it back to the client. Line 53 to 61. The button press function is called when a post request is received. It checks if the request contains data related to turning the light on or off and calls the corresponding functions. It then returns an updated HTML response. Line 64. This line starts the server and it specifies the IPv4 address of the Wi-Fi connection. The server will listen for incoming requests from this address. Line 68 calls the setup Wi-Fi AP function to set up the Wi-Fi access point while configuring a specified SSID and password. Line 69 calls the setup relay function to set up a digital output pin GP22 to control the relay. The relay is used to control the on and off of the USB light stick in response to user interactions with the web interface. Line 70 calls the setup server function to set up the HTTP server. It creates an instance of the HTTP server class, configures routes, and starts listening for incoming HTTP requests. Line 71 to 72. The main loop continuously pulls the HTTP server for incoming requests. It keeps the server running and responsive to client interactions. Well done completing chapter 7. In the next chapter, we will learn about light sensor and temperature humidity sensor. Thanks for watching, and I will see you in the next video.